So yesterday we started Chapter 6, Section 3. We saw what the unit circle looks like. Again, you need to remember or memorize the 6 trig functions and remember what they represent. Remember, before we memorized sine as y over r, cosine is x over r, and tangent y over x. Now, since r, when we're talking about the unit circle, always equals 1, we don't need to use the r for sine or cosine. All we need to use for sine is y, and for cosine just x. And then memorize the reciprocals. So again, you will have a quiz on Wednesday, filling in the unit circle. We may give you some questions where you're going to have to answer them and find the different trig function values using the unit circle. That we haven't finished finalizing yet, but for sure, you need to fill in a unit circle. So we did the examples here where we used the unit circle. Most of these questions were the quadrant angles. There were a few that were not. And we're going to do more examples of those at the end. This is where we used our calculators because notice all of these radian measures did not involve pi, so we didn't get them from the unit circle. And this is where we left off. Now, if you recall, back in your Chapter 5 Brown book, when we did this in that book, we were talking degrees. So again, this is my coordinate. So again, you've got quadrant 1 here, quadrant 2, quadrant 3, and you can do it with Roman numerals as well, but I'm okay with you just writing the number. Remember, from quadrant 1, if we use our acronym of all students take calculus, remember in quadrant 1, everything, all 6 are positive. In quadrant 2, the only ones that are positive are going to be sine and its reciprocal. In quadrant 3, the t stands for tangent and its reciprocal cotangent. And in quadrant 4, cosine and its reciprocal. These are the ones that are positive. The other 4 in each one of those quadrants would be negative. Now, when we were trying to find the different angle measures for theta, when we were doing, and this one we're going to do the calculator. So quadrant 1, this is where our reference angle is always located. When we did it in degrees, in quadrant 2, remember we did 180 minus the reference angle. Remember now, the value of 180 degrees in radians is pi. So what we're going to do here is 3.14 minus theta, which is our reference angle. So really what we're doing here is pi minus the reference angle. Over here, remember it was 180 plus the reference angle when we were in degrees. Now we're going to do pi plus the reference angle. And that's what that 3.14 plus theta represents. Theta is your reference angle. And then here we would be doing 360 minus the reference angle when we were in degrees. Now we're doing 2 pi minus the reference angle. Because if you think about it, 3.14 times 2, which is 2 pi, gives you 6.28. And that's how they get what's written here. So when we're using our calculator, if it doesn't say to use the pi button, you can use 3.14. And that's what we're going to do on the next slide. So here it wants us to find, now, sometimes they use the symbol theta. In all of these examples, they're using the letter s, the variable s, to represent the angle measure. So again, notice the restriction here. Before, when we did it in the Brown book, we were doing from 0 to 360. That was the degree measures. Now we're doing radians. So it's from 0 to 2 pi, or you can also think of it as 0 to 6 radians. So now let's go ahead and try our first example. Now for 16 and 17, there's actually a cosine button on your calculator. Remember, whenever you're looking for an angle measure, we're doing the inverse. So this is where you're going to hit your shift key or your second key. So what we're going to do here is cosine -1, put that decimal in, 0.9685, hit enter, and we're going to get 0.252. Now, let's do our all students take calculus, because whenever we are looking for an angle measure, we're looking for two answers. We're looking to see where cosine is positive. Cosine is positive here and here. So the answer I just got, the 0.252, and we're rounding to the hundreds place. So actually, let me get rid of that too, because the instructions say to round to the hundreds place. So 0.25 is my reference angle. This is an angle measure in radians that is located in quadrant 1. It's 1/4 of a radian. Now, to find the angle measure from quadrant 4, what I'm doing here is 2 pi minus that reference angle. And I'm just going to do 6.28 minus 0.25. And that's going to give me the angle from quadrant 4. So 3, 0. So quadrant 4, it's 6.03. 6 radians, which makes sense because 6.25 is the full circle, or 6.28 something is the full circle. So this is a reasonable answer for an angle in quadrant 4. So my two answers here are going to be 0.25 and 6.03. Let's try the next one. There is a cosine button again, same thing. We're going to do the inverse because we're looking for an angle. So cosine -1, 0.7826. You're going to hit enter. We are going to round to the hundreds place. So this is going to be 0.67. Again, this is my reference angle. This is almost 2/3 of a radian measure. So here we have our all students take calculus. 0.67 is the radian measure in quadrant 1. Again, quadrant 1 and 4 is where cosine is positive. Again, I'm going to take that 0.67, 6.28 minus 0.67, and I get 5.61. So the two answers here from quadrant 1, 0.67, and from quadrant 4, 5.61. Okay, so no COT button here for number 18. We know that cotangent is the reciprocal of tangent. So we know tangent of S is really 1 over cotangent. So what I'm going to do here is tangent -1, inverse tangent, 1 over, or 1 divided by, however you want to do it, and close the parentheses. This is approximately equal, rounded to the hundreds place, 1.28. Now again, let me draw my all students take calculus, because I'm looking for two answers. Never list, like if the reference angle is not one of the answers, do not list that on the line as one of your answers. But in this case it is, and in the other problem it was as well. So tangent's positive in quadrant 1 and in quadrant 3. So the answer we got from the calculator is the quadrant 1 reference angle. Remember, in quadrant 3, we're going to do 3.14 plus 1.28. Once I do this, I get 4.42. So the two answers here for the cotangent are going to be 1.28 and 4.42. Cosecant, same thing for number 19. There is no button on your calculator that has CSC. we have to use its reciprocal, which is sine. So with sine is equal to 1 over cosecant. So what we're going to be doing is sine -1, 1 over, or 1 divided by, and the decimal point should be, erase this one right here, it should only be 1.0219. You're going to hit enter. We're going to round to the hundreds place, 1.36. Again, we need two answers. All students take calculus. Cosecant is positive here and here. We just got the first answer from our calculator. To get the second answer for quadrant 2, I am doing 3.14 minus the reference angle I just got, and this is going to give me 1.78. So my two answers here are going to be 1.36 and 1.78. The last one on this page, again, is sine. Now, whenever you're looking for an angle measure, if you were to put this in your calculator as it is, if you do this, sine -1, and enter it as a negative answer, you're not going to get the reference angle from quadrant 1. You need to enter this as positive. That will then give you the reference angle from quadrant 1. This is when you change the sign, when you're looking for an angle. So we're going to hit the second sign, enter this as positive. Once you do this, you are going to get 0.35. This is going to give me the reference angle from quadrant 1. Quadrant 2, quadrant 3, quadrant 4. I need to see which quadrants sine is negative. Sine is negative here and here if you do your all students take calculus. The answer I got is not the answer to the question. It's just my reference angle. I now have to take that reference angle, add it to 314, and one of my answers is 3.49, and the other one, I'm going to subtract it from 6.28, and the other answer is 5.93. So the two answers from quadrant 3 and 4, where sine is negative, is 3.49 and 5.93. So again, if you want the correct reference angle from quadrant 1, you need to enter the answer in as positive. If you enter it in as negative, you're not going to get the reference angle from that quadrant. Let me see, negative 0.3425. If you do that, you're going to get negative 20.029, which is not in that quadrant. Now what we're going to do is it still wants us to find the angle measure, but now we're not using our calculator. Now, if this were an SAT question and it were on the calculator part, you could do inverse tangent, put in 1 and get the angle. However, if it's non-calculator, you need to use your unit circle or use your triangles. So for here, when we want to find where tangent is going to equal 1. So remember, I told you to memorize, remember the check to see if you're in degrees or not? When I tell you to do tangent of 45, you should be getting 1. So this is our example. Because if you look at the unit circle, none of the ordered pairs have a 1. But what we're really looking for tangent, if you remember, tangent is going to be y divided by x. So in order to get an answer, when you divide the y coordinate by the x, we're looking for two numbers that are the same on your unit circle. So if you notice, all of the angles that have a denominator of 4, these are all using the reference angle of 45. So once you figure out what your reference angle is and you know what other quadrant to look for, just look for the same denominator. So for example, on this one, we want to see where tangent is positive. So this is what I would do first. Narrow down which quadrants you're looking at. So here, I know that tangent is positive here and here. And if you've memorized that tangent of 45 equals 1, then you already know that your reference angle is pi over 4. So over here, notice the order pairs. The x and the y are the same numbers. Tangent is y over x. So if you do root 2 over 2 divided by root 2 over 2, anything divided by itself is 1. So here's our reference angle, pi over 4. And then in quadrant 3, here is the other one with the denominator of 4. So it's 5 pi over 4. So the two answers here for S are pi over 4 and 5 pi over 4. Let's try the next one. Cosine. We're looking to see where cosine is negative, so let's narrow down. All students take calculus. Cosine is negative here and here. Remember, cosine, all we need to do is look at x. So we're looking to see which order pairs in quadrant 2 and 3 have an x of the order pair equal to negative 1/2. So if I zoom in here to my unit circle, I can see that x equals negative 1/2 right here and right here. Notice when we're answering these questions, both denominators are going to be the same. So where cosine equals negative 1/2, our x value is 1/2. It is going to be at 2 pi over 3 and 4 pi over 3. Let's try sine, number 23. Sine, all we have to do is look at y. So I'm going to go ahead and narrow down where sine is negative. All students take calculus. Sine is going to be negative here and here. So I'm looking to see where in my ordered pairs sine, the y value is negative 1/2. So if I come on over here, my y value is equal to negative 1/2 right here. So I have it at 7 pi over 6. And here's the other one, 11 pi over 6. So the two answers here, angle S is 7 pi over 6 and 11 pi over 6. For cosine, again, cosine is going to look at x. Let me narrow down the quadrants to look in. All students take calculus. Cosine is positive here and here. I'm looking at my order pairs to find out where x equals the square root of 3 over 2. Come on over here. Where x equals the square root of 3 over 2, right here. And also right here at pi over 6. So we have pi over 6 and 11 pi over 6 from quadrant 4. Okay, I'm going to do a few more additional examples, especially to show you tangent, because tangent we got to work for. When it's sine or cosine, all we're doing is looking at the x and the y. Now, we also have to look at the reciprocals as well. So let me do a few more. I've actually added a unit circle here to do some more examples. So let's go ahead and let's find s when we're looking at secant. When secant equals positive 2. Remember, secant is the reciprocal of cosine. So what we're really looking for here is secant of s and where it's the reciprocal. Because remember, cosine of s is just x. Cosine just looks at x. Secant is the reciprocal of cosine. So we're looking to see where secant is equal to 1 over x. So what we're looking for here is looking for an ordered pair that where x equals 1/2 is what we're looking for. So again, let's narrow this down. All students take calculus. And I know that cosine is going to be positive here and here. And again, I'm looking for an x value that equals 1/2. So right here, oops. Right here and right here. So my two angles. So what we're going to do here is it'll be pi over 3 from quadrant 1 and 5 pi over 3. Because what you're doing here is you're flipping this answer to the reciprocal. And you're making it 1 over 2. And then that's what we're looking for when it's the reciprocal. Let's do tangent now. Let's look for tangent of s where it equals the square root of 3. If you look at your unit circle, there is no numbers on here that are just a square root of 3. However, remember that tangent is equal to y over x. Now, what you could do to make things a little bit easier for yourself is if you notice in the unit circle, there's only 3 sets of ordered pair types. You either have this one right here, root 3 over 2, comma 1/2. You have where they're both the same, root 2 over 2 and root 2 over 2. Or you have 1/2, comma, root 3 over 2. What they've done on all of these is just change the signs. So what might help you is if you go ahead and figure out what all of the ordered pairs, when you divide them, y by x, become. So the first one, if you took root 3 over 2, comma 1/2, and then if I do, this is x, this is y, so if I put it in here, 1/2 over root 3 over 2. This fraction bar means division. So what we're really doing here is 1/2 divided by root 3 over 2. Back to my 4th grade fraction skills, keep, flip, change it. So 1/2 times 2 over root 3. The 2 simplify. So now I'm left with 1 over root 3. Rationalize. I get root 3 over 3. So for this ordered pair, when I divide y by x, the tangent value is root 3 over 3. Over here, y over x, remember we already knew tangent of 45, the tangent is 1. Now I'm going to do this one, and I'm going to divide y by x. So when I'm doing the tangent of pi over 3, what I'm really doing here is y divided by x. So again, pi over 3 has 1/2, comma, root 3 over 2. So root 3 over 2 divided by 1/2. Keep, flip, change it. Simplifies. I get root 3 over 1, which is just root 3. So now, each one of these ordered pairs is repeated throughout the whole unit circle. Notice this one right here is the same as this one. The only thing different is the signs. So now, instead of being a positive root 3, it's a negative root 3. Same thing here is a negative 1, and then this one's negative root 3 over 3. Then down here in this quadrant, again, look for the same things. This is going to be negative divided by a negative. Remember, tangent is positive here. This is positive 1, and then this one's the positive root 3. Then over here, negative root 3 over 3, negative 1, and then negative root 3. So if you want to take the time and also memorize which order pairs give you root 3, which one gives you 1, which one gives you root 3 over 3, then you don't have to take the time of dividing it. So now back to my question. I had asked you to find what angle gives you square root of 3. So now that I've already divided this ahead of time, I can see that that angle is going to be pi over 3. So I'll come over here. So this gives me pi over 3. That's my reference angle. All students take calculus. Tangent's positive here and here. So now I just have to look in quadrant 3 to find my other angle that has a denominator of 3 in quadrant 3. And that's going to be, I'm sorry, I wrote the wrong, oh no, that has a denominator of 3. So that's going to be 4 pi over 3. Because my reference angle, when it's the square root of 3, is pi over 3, or the 60 degrees. Now let's try a different one. Let's do tangent of S when it equals root 3. Negative root 3. Let's do a negative. Negative root 3 over 3. So again, all students take calculus. Tangent is negative here and here. So again, if you've already divided the y by x, I'm going to go look on all these little numbers I wrote along the edge, right here and right here. So my two answers here are going to be 5 pi over 6 and 11 pi over 6. Will be the two angles when tangent is equal to negative root 3 over 3. Let's try another one. Let's do a cotangent. Now for cotangent, remember cotangent is equal to x over y. So again, you really don't have to go back and re-divide everything. For cotangent, these two are just going to switch places. The one's going to stay where it is. So for cotangent of pi over 3, it's just going to be, it'll change places with this. So these switch places. So let's say I wanted to find the cotangent. Find the angles where it equals root 3. So again, all students take calculus here and here. Well, I just fixed it. It's right here at pi over 6. And then in quadrant 3, I'm just looking for the other one that has a denominator of 6. Did I do that backwards? Let's see. Also, 7 pi over 6. Again, start memorizing the unit circle. Make sure that you understand what to do here. And know that for sine, you look at y, cosine, you look at x. Tangent, again, if you want to divide all these ahead of time and understand what the different values of tangent you can get, that's what you're going to do here. Now remember, if you're given an angle measure that is greater than something that's on the unit circle, then you have to add or subtract. So if it's greater, you're going to subtract 2 pi to get it to something on the unit circle. If it's a negative angle, you're going to add 2 pi to get it to something on the unit circle. and then you can just use the coordinates.